Aloha. I'm Paul Deslauriers for the Maui Community Investigation. And with me is one of my teammates and partners in all our investigation, Bruce Douglas. Bruce has over 20 years experience in working on exploring weather using satellite imagery, but looking at the engineering that has been happening to our weather systems, not only here in Maui, but also throughout the United States and even globally. So he's going to be sharing some of that data and information, especially around this big storm that we just had here in Maui. In my area, I mean, we had a 19.6 inches here in Kihei. And on the top at Haleakalā, there were 59 inches of rain that fell. So, Bruce, do you want to start by going into some of the dynamics that really created this storm?
Well, this was a Kona storm, a south storm. So Kihei got the brunt of it, and Haiku, the North Shore, was in the shadow. And it's the opposite of how winds usually are. So let's take a look at the PowerPoint.
Yeah, by the way, I've never experienced anything like this before in Hawaii. So this was a very out of the realm storm. And again, I think that we have to look at how that was created. So, Bruce?
Well, was the Hawaii Kona storm natural or engineered? I'm going to present the facts and the science and the images and let you decide for yourself. Of course, you know that flood. This is South Kihei Road, which received the brunt of the flooding and mud floods and everything else. Someone driving through it in their big truck, which people do on big trucks. And of course, what else do you do when there's a storm in Hawaii? Well, you surf it, right? So there were people surfing the floods, which is always a good thing to do when you're in Hawaii. So what I normally people think of cloud seeding, where you put silver iodide or other particles into clouds and make existing clouds dump the moisture that's already in them. That's not what I'm talking about. What I'm talking about is generating clouds out of thin air and creating the clouds, not cloud seeding. That's old school technology, been around a long time. We're talking about new technology of cloud generation. So this is an infrared satellite image of the Pacific region. So we'll do a region-wide thing. And these gray clouds right here is a normal tropospheric lower level clouds, like up to 5,000, 10,000 feet. And these up here are stratospheric clouds going a whole different direction. So you're going to see two layers of clouds. So I'm going to play it so you can just get an idea of what we're talking about here. Hawaiian Islands right here. This is starting with the Friday, just before the floods. This timing up here is universal time, which is a little below it, above before it. And you can see here's Friday the 13th when the flooding is starting. And you see down here these clouds like generated, this big puff right here, generated out of nowhere, down just south, like a couple of 100 miles south of Hawaii, flowing in the high-speed stratospheric winds and going on their merry way onto the mainland. And here's the grand finale right there, a big poof. So let's look at the wind patterns. We're going to first look at wind patterns at 2,500 feet, the tropospheric winds. And you see how it's making a circular pattern going around at the tropospheric level. Here's Hawaii down there. So this is what's happening in the lower atmosphere where all the clouds are and the normal weather happens. But if we clip up here to 30,000 feet, which is up in the stratosphere where planes fly, we see a whole nother pattern in the stratosphere. You see the high-speed stratospheric winds going, dipping down around Hawaii and then going north and then flowing back to the east toward the mainland. So here's the same time period when that's happening. And you'll see that the clouds in the stratosphere are going in the stratospheric wind direction toward Hawaii. And the gray stuff down below is following the tropospheric wind pattern. So I'm saying there's two different things happening. There's this stratospheric winds up here, right? And the lower level tropospheric winds make a circular pattern, completely different pattern. They're slower speed. They're still fast on that day, but there's certainly nothing like in the stratosphere. So the stratospheric winds at high speed with that same time period we looked at. And so you can see the two layers of clouds that we're talking about here.
Why is there such a distinction, Bruce, between the two layers where it's light gray versus the high contrast colors that you have between the
Well,
ionosphere
this
and
is a
troposphere?
colorized image. So basically, infrared sees heat or reflectivity. So temperature-wise, the higher in the atmosphere it is, the colder it is, and so it becomes more sharp and brighter. And also, if these aerosols, if we're seeing these, they have little nanoparticles of aluminum, barium, strontium, nickel, cadmium, and zinc. They have metal flakes in them, and they dominate the screen. So we have a couple different things happening here. And they've been colorized so that the gray and white is the normal cloud. And then as we get in the upper atmosphere, in the stratosphere, and it gets super cold, then it turns to blue and green and red. And when it's super dense, it goes black. You should only see black in the eye of a hurricane or something super dense. In this case, because it's highly reflective, it dominates the screen. And the normal clouds are down below. So the colorization helps to exaggerate. This is the thunderhead spectrum, so it really exaggerates the upper end of the spectrum so you can see the difference between the two cloud layers.
It's amazing what happens when you start to put nanoparticles then into the seeding process and how it creates a different reflection. So
right. So let's
interesting.
we're gonna come back and we're gonna show this again, but I want to give a little lesson so we understand what we're looking at here. So you see where it all comes from. At first, let's look closer right here where I'm talking about a cloud being generated out of nothing. I mean, there's no tropospheric clouds down below. It's all very thin clouds in the troposphere, but suddenly, as you can see, a point source, which I'm conjecturing is a ship out here that's got an aerosol generator on it that's making these clouds very close. And when they do this close into the islands, it creates a very extreme weather conditions. Usually it's further away, we get the stratospheric clouds, but when it's this close to the islands, you know, it makes an extreme weather pattern. And here's the grand finale right there that burst that got Big Island. And that's basically our flooding. It was not circulating around. It wasn't tropospheric. It was a whole different pattern.
So where you just pointed, Bruce,
Mhm,
back there, where it was emanating from,
mhm,
there was no other kind of uh, framework to create that
right.
other than injecting aerosols. So is it, because how else could it just kind of come out of the middle of the ocean with nothing else there, and all of a sudden, boom,
Well,
you get
normally you'd
this.
see that from a thunderhead. You'd see a bunch of tropospheric clouds. Up here, you can see there's a bunch of thick clouds. That's an
Mhm.
actual tropospheric cloud layer if doing it. But here, where this is happening, you don't see any cloud. You don't see a thunderhead forming and getting big, and doing its thing. It wasn't a thunderhead. It was very different. So let's talk about what a cloud generation. We have a technology. This is an old school. This is from the 80s. This picture's been around a while, but this is a machine that's creating a cloud, nucleating the moisture down in the troposphere where there is moisture, and it rising up and see this huge cloud right here and see if from a distance where it rises up and just keeps going up into the stratosphere. And the reporter that's watching this gets very excited because suddenly it starts raining on him. So that's old school from, 1980s. Okay, long time picture.
Yeah, and Bruce, I mean, they started back in the Vietnam War with
Right.
Operation Popeye. I mean,
Yeah.
that's when they first really started to weaponize that whole framework of using cloud seeding. So,
Yeah. Well, this is beyond cloud seeding. This is cloud generating. Very different technologies. Cloud seeding, you drop something in existing clouds and make them suddenly drop it, or you run frequencies in a cloud and make it drop its rain. This is like cloud generation, a whole nother phenomena. And here you can see, they got small ones you can put in the back of a truck. So here's one out of the back of a truck, creating a cloud, spraying out. And here you see it from a tank. used in military. You can buy these from military contractors, used to confuse the enemy and cloud the whole area and mess up the radar with these reflective metallic nanoparticles that are a part of it. Not anything I would want to be standing around while it's being sprayed. But you can buy those from contractors. So here you can see it going up. It goes with the wind down below, and then it rises up and catches other wind. And it makes this huge cloud just from the back of a pickup truck, from a small one. This is a mini unit, right? Imagine you mount a big one on a ship and what you might be able to get. In a very short amount of time, here's a cloud out of nothing, nothing else around it. Get the idea? Here's one you mount on a ship, also used to, quote, confuse the enemy to create a cloud. Again, you can buy them from military contractors. And you always have them mounted on all the ships. They all have these sort of cloud generating devices. And this is from a coal plant, a coal power plant. People are seeing this all over and seeing these big plumes rising up from a coal plant where normally there's scrubbers and most of the pollution is removed. But, on occasion, people suddenly see these clouds. And when you look at it, here's the cloud rising up, and here's how it looks from a satellite image, that same cloud being generated from this point that someone got the picture of, and how it looks from above from the satellite image, where you can see these point source here, very dense, rising up. And this is not colorized. This is a grayscale image, right? And here it is from another satellite image, that same point bubbling up from a coal power plant, creating a cloud out of nothing. And people reporting these around the country.
So they can generate this all over from the land as well as the sea,
Right.
and create these clouds that then can turn into some pretty nasty storms and hurricanes and tornadoes.
Right. But you see the same thing. There's no cloud layer around it to justify this sudden, massive cloud which shears and, blows off in the stratospheric wind direction very quickly. So what is it that they're spraying? A researcher named Marvin Herndon, San Diego, did this peer-reviewed article. It was actually peer-reviewed, then of course redacted, about evidence of coal fly ash being what's being used in these weather engineering operations. And he took like a HEPA filter, and on spray days he gathered up from a HEPA filter what's coming through and compared that to what is in coal fly ash. And these are all the minerals that you see: aluminum, barium, strontium, nickel, cadmium, zinc, on, in coal fly ash. And you see the same pattern in what's being gathered on a HEPA filter. Then he did the same thing with rainwater coming down and compared that, leach it from coal fly ash. We put coal fly ash in distilled water and you see what leaches out of it, and has the same pattern of the same minerals. He's hypothesized what we're using in coal fly ash, and it makes a lot of sense because when you burn coal at extremely high temperatures, it makes the minerals nano in size, really small at that high temperature, and it ionizes, it creates ions. And it goes up the smokestacks, and we have electrostatic precipitators on the smokestacks. We've been doing that since the 60s now, and pulling out the most toxic part of the coal with electricity. Since they're ionic particles, you can pull them out with these so-called scrubbers and get the nasty particles out, and then it becomes a waste product. What do you do with it? They've always had the problem. What do you do with this waste product of coal fly ash? Well, it appears like they're using it in the weather engineering, experiments. It emulates exactly what a volcanic eruption does, where a volcano, super high temperatures, high speed, it makes minerals nano and ionic, and it shoots it up in the stratosphere, where it shears off in the high-speed stratospheric wind and travels around the planet a few times before it precipitates back down again, which is what we see after a volcanic eruption. And then we got these boats here cruising around the ocean, which they call power ships. This is a series from a Turkish company, but other countries have the same thing. They're contractors for hire. And what they say is this is for if there's an emergency someplace, they'll float in and they'll create electricity But that's not what people are seeing. You're not seeing this actually appearing after, you know, some big disaster and suddenly these power ships show up. Um, what people are seeing is this is the cloud generation machines uh, that are, you know, cloud generation machines on steroids, like big ones, even though they claim they're power ships. I even saw an image of this in the Straits of Hormuz recently, sitting around with the Navy, one of these type of ships. Is that to create electricity, or is that to create a cloud in case they need to confuse the enemy and hide their theater?
Wow, compared to the size of that truck generator, compared to these monstrosities, my, what it be able to generate, it must be incredible.
Incredible. And I've seen images of the results of these things where suddenly the cloud just, you know, within a couple hours time, you got the cloud the size of a state, you know, covering the area in the ocean, you know, and then suddenly it starts to spin and makes a hurricane. I'm seeing these instant, very quickly generated storms. And these were also seen around that big storm that happened in Spain. As many people got pictures of seeing a couple of these ships plying in the water afterwards. So, you know, how do you get in the stratosphere where they have, you know, solar radiation management, they're trying to say, the quote, so-called geoengineers, the fake scientists who want to someday spray sulfur in the stratosphere to reflect the sun's heat and cool the planet and save us from global warming. Well, you know, the whole global warming agenda, it didn't quite pan out. When we started doing the math, yeah, we were getting warm for a while and we got cool for a while, and it's cycling with the sun cycles like it's supposed to do. So they changed it from global warming to climate change. Global warming was an assumption because the poles are melting, so it must be getting warmer, but that's not what you do in the math. But you see a volcanic eruption can shoot aerosols, you know, nanoparticles into the stratosphere, create a stratospheric haze, and travel around the planet and reflect a certain amount of heat. But then they're planning to, you know, put up weather balloons or planes or other things to inject, you know, nanoparticles into the stratosphere and reflect the heat in order to cool us. So that's their great plan. And I think what probably a lot of people who are involved in these programs thinks they're doing, you know, chemotherapy for the planet and saving us from global warming.
So, in other
Um,
words, this is a way to counteract then the breathing that we're doing and our carbon footprint, and also that of farting from cows and all of those
it's
different things.
et cetera, the whole agenda of the climate change agenda. But, you know, this is what they're proposing they want to do sometime in the future, not admitting that, hey, we've been doing this all along. They're just trying to normalize it and say, well, we had to do it because, you know, chemotherapy for the planet, you know, we would die without it. Um, but you know, all the different things they're talking about how to cool the planet down and create these clouds by putting it stratospheric aerosol injection. So they're trying to normalize this. But I mean, most people know about the HARP antennas in Alaska. Like this is old school technology from the 70s. It's now pretty much obsolete. We don't need any of these big arrays. We can do this inside of a little dome now. But these are ionospheric heaters. They aim radio frequencies at the ionosphere. In the stratosphere, there's a layer called the ozone layer, the ionosphere, and it heats up the ions, it excites them, right, and makes it hotter in a certain part in the sky and raises the sky up and creates a low pressure cell down below. And you suddenly raise the ionosphere, then down below, you create a low pressure cell. Um, and you can also interact with ions where the ionic particles are. So the aerosol clouds have ions in them, and you can interact with ions. Once you inject ions into the stratosphere, then you can move them around using these antennas, start spinning them in circles and making stratospheric hurricanes, which I've seen. This is the HARP dome, which is on a ship on a big platform. This comes into Honolulu Harbor on a regular basis. And this is not NexRad radar. Those are the spherical balls on a tower. These are these domes that we find around military bases, on military ships, and on these big platforms, able to interact with any ions in the atmosphere, whether they're the natural ionospheric layer or it's ionic particles injected into the stratosphere through weather engineering programs. That's a picture I actually took driving down the highway in Honolulu of the HAARP dome that you can see coming in for servicing on a regular basis. So I talk about stratosphere and where planes fly. It's important to understand this piece. Planes fly in the stratosphere above all the normal weather patterns. The troposphere is where all the weather patterns and the moisture is, and all of our clouds. Occasionally, a thunderhead will poke its way through the stratosphere, but it'll stay attached to the thunderhead down below. It won't just like move for long distances. But now, when we're flying, we see clouds higher than the planes fly. This layer up here is the ozone layer, a very important layer in our atmosphere, the ozone. And the stratospheric aerosols that are being blown off go higher than the planes fly and rise up to just below at the ozone layer and interact with the ozone. Not a good thing to be doing. So lower level.
Bruce, what's the impact of having that interaction with the ozone layer? Is it further deteriorating it?
I think it's part of the depletion of the ozone as the stratospheric aerosols. I think that Freon may have contributed, but I think that's a cover story. We have a layer of, stratospheric ozone that we didn't used to have. And this is what I'm talking about. This is a wing of an airplane. I'm flying. Here's the natural puffy clouds down below. And then there's this stringy, gooey, cotton candy looking clouds higher than the planes fly. So a plane flies at 35 to 38,000 feet in the stratosphere. And these are at 40 to 45,000 feet higher than planes fly in these stringy, gooey cotton candy clouds in an area where you cannot make a cloud in the stratosphere because there's zero moisture up there. The only way you get a stratospheric cloud is you generate it in the troposphere where there is moisture and have it rise up into the stratosphere, nucleated around these metallic flake particles. That's how you create these sort of clouds. And when I was a kid, I never saw clouds higher in the stratosphere. It wasn't until about 30 years ago, 25, 30 years ago, I suddenly noticed, what are clouds doing higher than planes fly? And answer, they don't exist. The only time you get a stratospheric cloud is at the North or South Pole, called a polar stratospheric cloud, where the stratosphere is half the distance of the Earth than we are at the equator. And the conditions can create polar. So if you look it up, stratospheric clouds, the only real references you'll see is polar stratospheric clouds. Otherwise, these things are ignored. They don't actually exist.
Well, they do now.
They do now.
And it's through some very interesting engineering, it seems like.
Very interesting. So when you're flying, and here we are just below these stratospheric clouds flying in an airplane, right? And you see these clouds up higher than the planes fly at 40,000 feet, where there is no moisture. It's dry up there. That's why planes fly up there, because the atmosphere is thin and dry and there's less interference patterns. But when a plane flies through a stratospheric aerosol cloud and you're breathing that stuff in, I believe that's the cause of what we call airplane sickness, where suddenly you're breathing that in, you land, you get sick that night, you think, oh, I got a bug or something. But when you actually look at the white blood cell count, you don't actually have the titers of a viral or bacterial infection. You got the titers of fighting a toxic load in the body, your body immune system revving up and getting sick, which is what I believe is what's happening. So when I fly, I look at the satellite images, and I fly quite often. And I know where these weather engineering projects are happening, and then I look for the flumes rising up. This is a very good picture right here where you see from out in the ocean, here we are, the plane flies, no clouds below us, and you see this cloud rising up above all the others and creating this whole cloud up in the sky higher than the plane flies. Let's take a look at this as you're flying, and you'll see the cloud generated at that point source going in the stratospheric wind direction. See, at first it goes in the tropospheric wind direction one way, and then suddenly it shifts and goes the other direction as it shears off into the stratospheric wind direction and creates this plume higher than the planes fly. We're flying underneath that plume.
When was this taken, this picture, Bruce?
A few years ago. I was actually flying to Indonesia at that point. They do a lot of this around 10 degrees latitude, which is a natural updraft zone of the intertropical conversion zone. And so a lot of these projects, there's a lot of moisture at 10 degrees latitude. It's a natural updraft zone, and there's existing clouds you can kind of hide it in. And yeah, there it is.
Well, you can't get any clearer than that in terms of that generation right from the ocean. I mean, how can that come out right from the water itself, right from the ocean, all of a sudden
All of
generate
a sudden
the,
rises above. So it's really interesting when you fly and above and you see these plumes rising up corresponding to what I see on the satellite images. And what we're getting now is we're getting a stratospheric haze across the planet we didn't used to have. Now, the only chart I could find actually ends in 2009. I haven't found any charts referencing it since that time. Um, but the numbers are continuing to rise of a stratospheric haze in the stratosphere that we didn't used to have. Now, this right here was caused by this volcanic eruption in 1995, which blew a bunch of particles into the stratosphere, which it does, and then over the next year or two, it precipitated back down like it normally does, and then comes back to a baseline level. And then something around, the year 2000, which is about when I really started noticing the weather engineering programs pick up. And we've had this continual rise in stratospheric haze, which is reflecting a certain amount of light away from the planet that should be hitting the planet. So now that I've told you this, let's look one more time at this and see if we can see the pattern of, the two different patterns of the tropospheric and stratospheric weather, the clouds generated from a point source out of nowhere, and this is before the actual storm happens. And then boom, this is when the storm starts happening right here. And you can see the clouds generated from this point right about down here, only about 300 miles away from Hawaii. That's close in. And I noticed when they do these big, like there's a big blast. That was the big storm that hit Kihei and flooded everybody at that point right there. And that was the big one. They did all that damage over a day and a half's time period. And then they kind of left Big Island out. So at the end, they do one last little puff just to get sure we blast Big Island and make that flood as well. And there it is. That's the storm in 30 seconds.
So, Bruce, as that trail then goes to the mainland, could you explain then what's happening as it hits the mainland?
Well, they're predicting big storms and snows on the mainland when warm, moist air comes up from the stratosphere, follows the stratospheric winds, and then shoots out across the planet, or shoots out across the mainland. Then that will interact with the cold weather at the upper latitudes and create massive snowstorms, which is exactly what's happening right now on the mainland. So it started out down here, travels across the ocean, hits the mainland, and the big storm patterns from the mainland happen there. They actually call them atmospheric rivers now, a new phenomenon never seen before since the era of climate change. And I'll often see a spiral along with this atmospheric river. Like over here, there's a spiral happening, right, around the quote Kona low, but the clouds we're getting have nothing to do with the Kona low. That's way up here. So this is the Acapulco hurricane, Hurricane Otis, that hit Acapulco, Mexico, and slammed it. This is an interesting one because it shows cloud being generated out of nothing. You'll see right here this big poof injection go into it, right? And then suddenly it starts to spin out of nowhere. The hurricane, alleged hurricane, had already died, and then suddenly it spins really fast, slams into the coast. There it is, spinning in no time at all, and it slams into the coast, and then it quickly dissipates. That's an example of a hurricane generated basically out of thin air. I'll go back again. And you can see that it had basically broken up right here. It was just a storm out there in the ocean until an injection comes in from the side. So let's watch this again. You see the storm pretty much done, not spinning. Here's a poof injection from the side into it. Then there's about 5 hours missing from the weather satellite image, and then suddenly it spins up. I don't know why those 5 hours are missing, but something else was happening there. They didn't want us to see, likely. And in a short amount of time, it spins into a Category 4 hurricane. But it's interesting, it didn't have a lot of moisture with it. It was mostly dry. It was spinning, caused a lot of wind damage. But it was like, where's the rain? It was spinning. And if you look at these carefully, you'll see how there's clouds traveling, drifting right underneath this hurricane, unaffected by what's happening in the stratosphere above. So what I conjecture is they injected aerosols in, it rose in the stratosphere, they used HARP antennas or ionospheric heating antennas to interact with the ions, got it spinning really fast in the stratosphere, which of course funneled down and created the funnel and the dry hurricane that hit Acapulco out of nowhere. No one was ready for it. No one expected that to happen.
The damage from that storm in Acapulco was really abnormal. It looked like there were scalar waves that were utilized also in terms of how everything was sucked out of buildings, you know, and whole sides of buildings were taken down. It was a very, very strange aftermath from that storm that was far from normal, that's for sure.
Yeah, far from normal. And just like Lahaina, it was a ocean, is a very popular beach location with very valuable real estate that got devastated. And I'm sure somebody came in and bought it up for pennies on the dollar and redeveloped it.
Isn't it amazing how so many of these storms and catastrophes are being targeted to these areas that have high value and high potential? LA is a good example. You know, we call that Lahaina 2.0, and it follows many of the same anomalies that Lahaina had. So again, I think that when we start to look at things very objectively and clearly, like you're doing here right now, Bruce, I think we can start to come to a different level of conclusion in terms of what we're being told versus the reality.
Right. So let's look at Texas. So this is the Kerrville storm, the flood that happened in Texas. It flooded a river and killed many people along the river, including that camp where many people were camping alongside the river. Suddenly a storm comes out of nowhere. So we're going to look at this and see if we see that same pattern of a point source generation of a storm. So here you see right here at Kerrville, boom, a cloud coming out of nowhere, going all directions, even against the wind, right? Generating against the wind, this dark cloud, boom, creating massive rain and massive flooding. And then, there you see it near Kerrville, there above North and Junction, another bigger one for their grand finale, which is upriver from that, just to make sure the flooding goes all the way. Now, what's interesting you see here is people from the sky looked at that, looked at satellite images, it looks like the clouds don't move, right? But what's happening is they're generating the clouds from a point source and then goes against the wind, and then suddenly, as quickly as the thing came and arrived, poof, it's all gone. Again, dumped all that rain in a short amount of time.
Could you show with your cursor the direction of the wind that was normal versus what was generated?
So you look again, the winds are going toward the south at this point, right? And you see the clouds, normal clouds, everything moving to the south. And then when you see the explosion happen, looks like an explosion, although it's not. It's a big, what I'm conjecturing, an aerosol generator that's sequestering this moisture and shooting it out. All of a sudden, it goes against the wind. It goes against the wind the other direction. Then the wind finally catches it and makes it go again. So let's watch that again because it's really obvious now that you can see this. So right around Kerrville, boom, going out in all directions, even against the prevailing wind. A big blast from one point source. A couple times, you see another one there, going against the wind. And then the wind finally catches up with it and it starts blowing in the wind direction once it stops being generated. And another big blast to the north, covering the whole area and creating the massive flood, which cost many lives.
And some places that it rose 40 feet, over 40 feet, that river.
Right. instant. Now, what I can't see is how they're doing, you know, since there's ions in the particles that are being sprayed, that ionic radio waves can interact with it. And they could play frequencies on it with all sorts of technologies we have these days where you can suddenly make it dump its rain really quickly. So you sequester the moisture. There's a lot of moisture in the atmosphere. That's why these generators can just like, once you nucleate it, you create a nucleus for it to come back on, then, it has the ability to grab the moisture because that's just like a cloud is taking dust particles and nucleating the moisture into a raindrop. So just give you a way how you can tell what a stratospheric cloud is versus a stratospheric aerosol cloud is versus a natural tropospheric cloud. This is the Maui sunset. And you see the sun is set over there and all the natural clouds have gone gray. One's over the mountain, but then these clouds light up, up in the sky. And these are the stratospheric clouds because they're so high up that even though the sun has set, the clouds have the ability to light up from the underside. They call it noctoluminescent clouds, a new phenomenon never seen since the era of climate change. They had to give it a new name because it didn't exist before. Noctoluminescence, nocto night luminescing clouds, clouds that light up, and you'll see at the sunset time. And I have this eerie pinky color to it, even though people may think, oh, that's a beautiful sunset. If you don't know what it is, I know what it is, so it's not as beautiful to me, but it still looks very beautiful and colorful the way it lights up from the underside of these clouds at 40,000 feet, whereas the natural 3 to 10,000 foot clouds have already gone dark down below. And that's a really good way at sunset to give a definitive look. Between that and looking at satellite images, you can really tell.
Well, we have part two of our video on weather. It's incredible what has happened here in Maui, Hawaii. I mean, it is a 1,000-year-plus storm. And it didn't only stop after this initial storm. We had a second wave. And Bruce is going to go into the specifics of how that was engineered and what we need to look for in future types of incidences like this. Bruce, you want to go for it?
I'd love to. Let's go back to the satellite image. Okay, we're back to the infrared colorized satellite images, loops put together into a coil. What I want to show here is that this part two of our storm, the Kona low that was up here before, that circle, that spiral that was created, either existed or created, is gone now. The trade winds have actually come back. You see the trade winds going, uh, even though what's underneath the storm is Kona. So we're going to look again. We're going to let this roll, and you're going to see right here a blast that hit Oahu, another blast here that hits it up. We're going to see a lineup of storms all together, and we're going to see another big one that whomps Maui, and then there's something far away here that's created that blankets the islands, and particularly a big island with rain. And then we're going to see here over this 10-hour period, this is really interesting here, a boat, let's back it up here, a point source creation of aerosols, shall we say, going about the speed of a boat over about 14 hours. You're going to watch 14 hours of time between, 5. And again, this is universal time up here, so Hawaii time is 10 hours earlier than that. But you're going to watch a 14-hour loop of this point source travel across the ocean toward the mainland about the speed of a boat. And there it is, our point source creation aerosol flying off into the sunset. So let's go back and look at that one more time, because I want you to see that there's no spiral of a Kona low up here. I want you to see the two distinct layers of clouds movement. And then we're going to come in a close shot and look at it more closely. So here we go. There's a blast that hits Oahu. There's a one that whomps Maui. And there's the line of storm of cloud generation all in one line. One more big whomp that hits Maui and drenches us over here. Then a source further away from the islands, kind of drenching the whole islands in rain. and our point source creation of aerosol generator floating off in the sunset, or I guess to the east would be the sunrise. What do you see with
So,
that, Paul?
yeah, could you point out with your cursor where the point source is for this? There we go. Yeah, so that we
Okay,
can.
so right here, this point source is right here. And when I let that run, we're going to let that flow, and you're going to see it go across this way, across the ocean. Over 14 hours, let's calculate that out. That's about the speed of a ship, you know, creating aerosols from a point source floating off into the sunset. Here it is right here. You see the flying off right there, going about the speed of a boat across the ocean like that. Point source V going up into the stratospheric directions, and this whole blast of aerosols, you notice where it goes. It's going across to Washington, Oregon State. It's dipping down into the central of America where there's big snowstorms happening because this is moisture-laden clouds from the tropics going up north, mixing with cold polar winds and dumping a big snow load on the Midwest at that point. So let's go to a close-up. And this is also colorized infrared, a different system that I look at. It's called clean long wave infrared, band 13. And we're going to start on the 19th when we had our reprieve and we have a day or two without big rains. And then suddenly there's something that whomps up Oahu right there. Boom, just upwind from Oahu. Saturates Oahu. That's the big rainstorm they had on that day, right? Then there's this big whomp right here that hits Oahu. It's Maui and Molokai. And you see the lineup of clouds in a straight line and more aerosols, particularly aimed at Maui.
Show where the aerosol
Well, let's finish it here. Here's the grand finale here where there's a big aerosol from a distance and some close up as kind of saturating the sky all the way across as a grand finale. So what do you want to see, Paul?
I want to see the point source as to where it generates from, because if that are ships out there, like what 40 miles offshore.
Mm-hmm. Well, here's one between Kauai and Oahu. This is the one at this point right here. This is universal time on the 20th. So it's the night of the 19th when the big rainstorm's happening on Oahu. You can see it right there, a point source setting Oahu. And then you see a point source here creating it against Maui, these puffs. Then you see this lineup right here where there's three in a row, and it stays fairly stationary right here, right? So that's what I'm talking about by a point source. And it stays in one place as the winds are going, and these are high-speed stratospheric winds. So these aerosols are rising up past the lower troposphere where all the clouds are, the low-speed clouds in the troposphere where it only moves like 15, 20 miles an hour. Going one direction, it rises into the stratosphere, it hits the high-speed stratospheric winds and shears off going that direction, which is a different direction than the tropospheric clouds down below are going.
So Bruce, what I understand is then that when you have a point source, it's just fixed in one position. It's not moving as a normal system would move. Then that goes up into the higher atmosphere where, again, trade winds make it take off at a higher speed in a different direction than it would normally happen if it was just, a normal cloud formation.
Right. Now, the trade winds is what's down in the troposphere, the lower atmosphere. And our trade winds go 15, 20 miles an hour generally, something around there. Stratospheric winds go a different direction and they're high speed. They're going like 100 miles an hour. That's up where planes fly, where there's no moisture in the air to create a cloud. You can only create a cloud in the troposphere where there's moisture, sequester it down here. It rises and hits the high-speed stratospheric winds and shears off. And that's what you're seeing with these point source creations. Let me do one more. this is the miso version, which they do every 2 minutes. They do a high resolution whenever there's an event happening. They'll publish this, and they're shorter loops, and I have to get them together, so they're kind of sketchy, the ones I piece together. But you're going to see a much slower speed going right here, where you can really see, and I'll put the cursor at the point source, you know, where it's like you can see how point source stays in one place, generally creating the cloud, while the and here's where another thing where it lines up into this line right here, a couple of different point sources. This one right here in particular is Wamping, aiming right toward Maui and Molokai. And here's the bigger blast that's coming from further away, you know, where it's doing it. But notice over here, the normal trade winds over here are back. The trade winds are going from the out of the northeast, this direction, slow speed. Yet underneath this layer of stratospheric cloud movement, we're getting Kona winds right here with no Kona low. So the Kona low is gone. There's nothing like that out in the ocean. They're still calling it a Kona low storm, but I'm calling it, an aerosol, stratospheric aerosol storm precipitating down on us, creating these heavy rains. I'm going to play this again. Do you have any questions in this, Paul, to clarify?
Again, the key is point source and then how it travels. And I think that's getting there pretty clear. And also the difference between the different types of cloud formations and
Right.
how they travel.
When you understand the different layers of cloud, you understand better what you're seeing here. So that's why I'm trying to describe this, so you can really see how high speed stratospheric winds, slow speed tropospheric trade winds down below. You'll see up here, if you look around the area of Kauai, you'll see the trade winds actually going in the normal trade wind direction, not Kona at all. The only place is Kona is underneath this whole streamer of stratospheric aerosols, creating an upper atmosphere disturbance that's moving the Kona winds underneath unnaturally, because the natural flow of all the clouds is up over here. It's different underneath this cloud layer. Let's look one more time. Nice and slow, high density. You can really see something from a point source.
What's the difference colors between the red and yellow and the green and blue?
Well, the yellow and red and black is the highest density. It's either highly reflective or colder. In the stratosphere, it's very cold, so anything up in the stratosphere is naturally going to get colorized because it's cold, right? It's also going to be infrared sees either heat or reflectivity. So it's also, if it's got nanoparticles of it, aluminum, barium, and strontium, nickel, cadmium, zinc, it's going to be highly reflective. So it's going to dominate the screen. So then also it's going to carry a lot of moisture with it, because that's the whole point of these clouds, a lot of moisture. So it's going to be reflected from moisture. So infrared sees heat or reflectivity. So, the blue is less, the green is more, the yellow is even more, the red is even more, and the black is like super dense. You should only see in the eye of a hurricane. But with that, let's look at this slow speed again, this high resolution, many pieces together so you really see it. And you can watch a point source creation of clouds out of nothing. There's no tropospheric clouds or thunderheads down below in order to generate these things. You don't see any of it. You know, Generally, if you see something, it should have a cloud formation underneath, a nice thick cloud bank that's creating thunderheads and stuff. And this is the final blast that's coming from further away outside of the screen. You can also see some of it here locally. And again, the Kona winds are being generated by what's going on in the stratosphere, because you see we have our trade winds have returned here, even though directly over the islands we have Kona winds. So what do you think, Paul?
I think as people become more and more educated, I think that they look at weather very, very differently. I certainly do. After all of the work and exposure that you've done over the years, uh, we certainly suspected some type of geoengineering, weather engineering happening, but to start to see it more clearly and understand how they utilize the different cloud layers, how they sequester moisture in the upper atmosphere, how they create these different streams of moisture within there. I guess atmospheric rivers, they're calling it. So
Yep.
again, well, it's amazing how all of these things have been emerging, and even they're using now different terms for the different weird cloud formations that are man-made. Like what is it with the
Noctiluminescent clouds.
so
Only
there you
seen
go.
since the era of climate change. Stratospheric clouds that never used to exist. When I was a kid, there were never clouds higher than planes fly. That was always below us. I'm a keen observer. I remember that. It wasn't until about 25, 30 years ago, really, I started seeing clouds higher than planes fly. And that's the key. You only have to know one thing. Why are there clouds in the stratosphere when the textbooks all say the stratosphere cannot make a cloud because there's no moisture up there? Ask that one question, you know, and
Well, that's
everything
that's a
else follows after that.
that's a good one for everyone to reflect on, to really get that, hey, wait a minute. you know Again, people want proof. Is this real climate change, global warming, or is there other things happening to our weather conditions? And it's certainly, as you keep on digging and looking at all the wide range of use of energy wave technology, we start to see all these different things. Not only that, but also weaponization. And that's what we dealt with in Lahaina. And there's a book that we're about to publish, and that'll be happening in April. We're going to be putting it out near the end of April. So again, look forward. But I think it's something that exposes not only what happened in Lahaina, but also how we can change things through our group dynamics and really create systemic change, which we desperately need at this time.
And it all starts first with awareness and understanding the right concepts. So we're not barking up a tree, but we're barking at where it's actually coming from.
Yeah, and these are good motivations to start to become better educated as to what is happening to our lives, our society, our weather, and our environment. So
So back
thanks,
to the final
Bruce.
question. Was this Hawaii Kona storm of March 2026 natural or engineered? I'll let you decide. Thank
There you
you.
go. Aloha.
Aloha.